Okay, Tam, welcome to a video tutorial on similar triangles. Today we're going to have a look at triangles that are similar. There's similarities between them. They're not absolutely congruent, but we're going to look at ways that we can work out if a triangle is similar or not. Okay, when we look at two objects, when we say similar, what I'm trying to say is they might be of a different size, but they generally have the same shape. So they might be different, but the measurements are kind of in the same proportion. So if one's 10, the other one's going to be 5. There's a proportion. The 10 one is double the size of the 5, if that makes sense. Let's have a look at some examples. Okay, let's have a look at these two. Now, side AB down the bottom here correlates with side DE on this side here. So side DE, okay, is 10. Okay, side AB is 5. That's their comparison. DE is 10, AB is 5. And if I divide 10 by 5, I get an answer of 2. Side EF over here, EF, okay, is 16, compared to proportionally side BC, which is 8. Okay, 16 divided by 8 is 2. Finally, side CA, okay, compared to side FD, FD compared to CA, my bad. FD, start with the bigger one, compared to side CA, I've got 14 over 7, that's a weird 7, 14 over 7, which again gives me 2. Now, because I have the same proportions on all of my sides, these triangles are similar. Unfortunately, unlike yesterday with congruency tests, it says prove that the pairs are similar, not just what proof do I use. So I do have to do 1, 2, and 3 in order to answer the question. Okay, let's have a look at this example here. Okay, so side on this one here, we'll say you take this one, side DE here is 3. Okay, so side DE equals 3. Okay, now its corresponding side, so the 80 degrees was at the bottom, 80 degrees at the bottom, its corresponding side is the 2 going up. Okay, so its corresponding side was AB, which is 2. Okay, 3 divided by 2 equals 1.5. Okay, let's have a look at the other side. Okay, so from the bottom of the 80, that's 3 going that way. So side AC, okay, is 3. And then going the other way here, it's 4.5. Side DF is 4.5. Always have to make sure I have the bigger triangle on the top. 4.5 divided by 3 is 1.5. So they're in the same proportions, which is a really good sign. Also, angle EDF, so this guy in here, is equal to angle BAC, this guy in here. So, yeah, like the other example, they are also similar. Okay, this example, sometimes I'm not just asked to prove that things are similar, but knowing that things are, use that information to find out other things. Okay, I know that that side's 4 and that side's 2. Okay, first off, the very first thing I need to do is find the proportion. Okay, DE, and the angle's in there, so they're the same sides, yeah. They definitely match up because that's there, and they seem to align. So DE, what's the proportion of DE over AB? Well, it's 4 over 2. 4 divided by 2 is 2. So it has a proportion of 2, okay? So if that one's 3, and that's the smaller one, x is going to be equal to 3 times 2, which is going to be 6. They're the two kind of things you need to do, guys. 1, prove that they're similar, or 2, use that information to find unknown angles or sides.